All right, buckle up, everybody, because today we are tackling a seriously big topic.
Oh, yeah.
The edge of the universe.
Out there.
We're using this transcript we found called Setsane.
Okay.
It's from a show called The Astronomical Minute.
Interesting.
And, well, everybody wants to know, right, what's out there?
The big questions.
The big questions, but it's not just about what's out there. It's also about how we figure that out.
Yeah, the science behind it.
The science, the tools, and then there are some mysteries, that we'll bump into along the way.
Always mysteries.
Always mysteries. So to kick things off, the Astronomical Minute, this show uses a really smart way to get us thinking about the scale of the universe.
Okay, yeah.
So they start with something we all kind of get,
Mhm.
light travel time
Okay.
from the moon to Earth.
1 second. Little over 1 second.
Yeah, just over a second, right.
Yeah.
But then they compare that to how long it takes sunlight to reach us.
8 minutes.
8 minutes. So already you start to feel that difference.
Huge difference.
Huge. But then hold on to your hats, because to cross the observable universe
The observable.
at the speed of light,
Whoa.
93
Billion.
billion years.
That's a long time.
Does a number that big even make sense?
It's almost impossible to comprehend, really.
It is, and it really just emphasizes that the universe is huge.
Astronomically huge.
Astronomically huge. And it makes you wonder, too, if it takes light that long just to cross what we can see.
Right. What about what we can't see?
What about beyond that? Right.
Exactly. It sort of hints at the limitations of our current understanding.
Exactly, because we can only see, well, what light has had time to reach us
Yeah, since the Big Bang.
since the Big Bang. And that's a whole other topic. But,
Right.
okay, so we've got this mind-blowingly vast universe.
Hmm.
But the Astronomical Minute goes on to tell us it's not just stuff scattered randomly.
Right. There's a structure.
There's this underlying structure to
A
it,
framework. A web.
like a web. And they call it the cosmic web.
Love that.
I know, right? It's such a cool name, and it makes you think of
Connections.
connections, yeah, like filaments, these long strands of
Galaxies.
galaxies, gas, dark matter,
Dark matter, all stretching out.
stretching out for hundreds of millions of light years.
It's like the backbone of the universe.
The backbone, I love that. And between those filaments, well, you've got these
Voids.
voids, like cosmic deserts, right?
Huge empty spaces.
Empty, but not completely empty. Right.
Well, there are traces of stuff,
there are traces.
faint traces of gas, dark matter.
So it's like these whispers of the past.
Whispers of the past, exactly. And that raises questions too, doesn't it?
Oh, yeah.
What happened in those voids?
Yeah.
How do they shape things?
It's like a whole cosmic detective story.
Exactly.
And this leads us to another fascinating point that the Astronomical Minute brings up.
Okay.
They say that looking further into space
Mhm.
is basically
Like looking back in time.
looking back in time.
Yeah, it's a time machine.
It is, and it's all because light travels, well, at a certain speed, right?
A finite speed.
Finite speed. So when we see a distant galaxy, we're seeing it.
Not as it is now.
Not now, but as it was billions of years ago.
Brilliance, yeah, when the light left it.
When that light started its journey, so the further away something is,
The older the light.
the older the light, it's incredible.
Incredible.
And they actually talk about this image, the Hubble Deep Field.
Oh, yeah, that's a famous one.
It's like looking back at the universe when it was
Less than a billion years old.
less than a billion years old. And the galaxies, they're like
Baby galaxies.
baby galaxies. They look so different from the ones we see closer to us.
Smaller, more irregular.
They're just starting to figure themselves out.
Exactly. And that's why those distant observations are so valuable.
They're not just pretty pictures.
Not at all. They're clues.
They tell us about the evolution of the universe.
The whole story.
The whole story. And speaking of the universe's early days, that brings us to the ultimate cosmic time machine.
Let's
Or the cosmic microwave background.
the CMB.
The CMB, it's like the universe's baby picture.
The ultimate baby picture.
The Astronomical Minute emphasizes that the CMB is so much more than just a cool picture.
It's data.
It's a goldmine of information.
About the very early universe.
They describe it as the afterglow of the Big Bang.
The faint radiation that's been traveling for, well, pretty much the entire age of the universe.
Over 13.8 billion years.
Think about that journey.
I know, it's incredible. And here's where it gets even wilder. By studying these tiny, tiny temperature variations in the CMB.
Variations.
Yeah, these little differences.
You can learn about the distribution of matter.
Matter, early matter,
Dark matter.
the role of dark matter, and even clues about the universe's ultimate fate.
Wow.
It's like the CMB is a map.
A map of the early universe.
A map, but instead of continents and oceans, it shows us the seeds
A lot
of
of the structures we see today.
the galaxies, the clusters, everything. And for now, it's the edge of
The observable
the
universe.
observable universe. Anything beyond that, well, we just can't see it, at least not yet.
Not yet, but who knows what the future holds.
Exactly. Science is always advancing, new technologies, new ideas,
Pushing the boundaries.
pushing the boundaries. So who knows? Maybe one day we'll be able to see beyond the CMB and get a glimpse of
The truly unknown.
the truly unknown, the stuff that's hidden from us now. And that is where we are going next in our deep dive.
Can't wait.
We're going to explore the possibilities, both scientific and speculative, of what might be lurking out there beyond the edge of what we can currently see.
Buckle up.
Buckle up, it's going to be a wild ride.
It always is.
It always is when we're talking about the universe. Okay, so we've made it to the edge of the observable universe at least.
The very edge.
And we've looked back to the universe's baby pictures.
With the CMB.
With the CMB, but now, well, we're staring out into the great unknown.
Beyond the cosmic microwave background.
Beyond what we can see, what's out there.
That's where things get really, really interesting.
Oh, yeah.
Because now we're moving from observation, hard data,
Right.
to speculation, to theories, a bit of imagination too.
I like where this is going.
The Astronomical Minute presents some leading theories.
Okay, lay it on me.
And honestly, they're all mind-boggling.
All right, hit me with the first one.
Okay, so first up, what if the universe just keeps going?
Like forever?
Forever. An infinite expanse of galaxies stretching out beyond what we can see.
Whoa, so just imagine you could travel past the CMB. What would you see?
Would there be more galaxies? Different galaxies. More stars, more planets. Would there be life?
Is there another me out there somewhere?
That's a really interesting question. And, some physicists say,
Yeah.
if the universe is truly infinite, then statistically,
Yeah.
anything that's possible, however unlikely it seems, has to happen somewhere.
So there's a me out there riding a unicorn, playing the banjo.
Maybe it's all about probability in an infinite universe.
Infinite universes, infinite possibilities. Okay, I'm starting to get a headache.
It's a lot to process. But wait, there's more.
More. The Astronomical Minute has more.
Oh, they've got more. All right, they bring up the concept of the multiverse.
Multiverse, like multiple universes.
Multiple universes, yes, all coexisting. But get this.
What?
Each universe could have its own set of physical laws.
Whoa, so like different physics in each one.
Imagine a universe where gravity works in reverse or time runs backward.
Okay, now my brain is officially melting.
But we're not done yet.
There's more. Okay, I gotta hear this. What else could be out there beyond what we can see?
Well, how about this? What if space itself is curved?
Curved? How do you mean?
Like curved in a way we can't even perceive. Imagine a universe that's finite. It has an end,
Okay.
but it's also unbounded. So if you travel far enough in one direction,
Yeah.
you could end up right back where you started.
Like looping around.
Exactly, like a cosmic game of Pac-Man.
That's
The reality would be far more complex, of course. But it's a cool thought.
a finite yet limitless universe. Mind-blowing, but hold on, we can't forget about dark energy.
Yes, dark energy, the big mystery.
The force that's pushing everything apart faster and faster.
Accelerating the expansion of the universe.
You can't see it, can't touch it, but we know it's there.
It's like this invisible hand shaping the cosmos.
And the Astronomical Minute says it makes up like 68% of the total energy density of the universe.
It's the dominant force, but we still know so little about it.
So what does dark energy mean for what's beyond the observable universe? Does it change things?
That's a great question, and it's one scientists are still grappling with.
Mm-hmm.
Some theories suggest that dark energy could be like fueling the creation of new universes.
Like constantly adding to the multiverse.
Exactly, while others propose that dark energy might eventually, rip apart the fabric of space-time.
Rip it apart? That sounds a bit terrifying.
A bit terrifying, yes, but it also speaks to how much we still don't know.
Right? About the universe, about its ultimate fate. I mean, it's all pretty humbling.
It is, to think we're just starting to scratch the surface.
Yeah, and I have to say, with all this talk of the unknown, I'm feeling kind of, inspired.
Inspired.
Yeah, it's amazing what we've already learned, but it's even more exciting to think about what we might discover next.
And discoveries don't always come from just telescopes and equations.
What do you mean?
Well, the Astronomical Minute talks about the role of imagination, even science fiction.
Oh, right, like sci-fi inspiring real science.
Exactly, think about it. So many technologies we have today.
Okay.
Smartphones, video calls, space travel. It was all once science fiction.
It's true. So what seems impossible now, well, maybe tomorrow it won't be.
And that brings us back to the human element of exploration.
The human element.
We're not just passive observers,
Yeah.
you know? We're active participants.
We build the instruments, we ask the questions.
We try to piece together the puzzle.
And in doing that, we're not just learning about the universe, we're learning about ourselves.
Our place in the grand scheme of things, that's what the astronomical minute reminds us.
It's a journey of self-discovery as much as it is a journey of cosmic exploration.
Exactly. So, now that we've explored the mind-boggling possibilities,
The what-ifs.
the what-ifs, why don't we shift our focus to something a bit more concrete?
More concrete.
Let's talk about the tools, the technology, the amazing instruments that are allowing us to peer deeper and deeper into the mysteries of the universe.
Okay, I'm ready to explore the cutting edge of astronomy. Let's do it. You know, it's kind of wild to think that it wasn't that long ago we were stuck down here on Earth.
Limited by our earthly perspective.
Exactly, all we had were telescopes on the ground, but now
Now we've got telescopes in space.
space telescopes, robots on other planets.
Scientists smashing atoms together.
It really is a golden age of discovery.
It is, and the astronomical minute, they highlight some of the key players in all this.
Okay, who do they mention?
Well, they talk about the James Webb Space
The
Telescope.
James Webb, yeah, it's already changing everything.
It is, think about it, capturing light from galaxies that formed.
Just a few 100 million years after the Big Bang.
Like looking back to the very dawn of the universe.
And the images, they're just incredible.
Stunning, but it's not just about the pictures.
Right. It's the data.
The data, it's giving us so much information about how galaxies form, how they evolve.
We're seeing the universe in a whole new way.
And it's not just telescopes that are helping us unlock these secrets.
Okay, what else? What else is out there?
The astronomical minute also mentions the Large Hadron Collider.
The LHC?
The LHC, yeah, it's like a giant microscope.
A microscope for the universe.
Well, for the tiniest particles in the universe.
Okay.
By smashing these particles together,
Yeah.
they can recreate conditions that existed just moments after the Big Bang.
Whoa, so we can study the universe's birth right here on Earth?
In a way, yes, and it's giving us incredible insights.
Like what?
Well, they're learning about fundamental forces, the nature of dark matter, dark energy, even the possibility of extra dimensions.
Extra dimensions, that's a whole other rabbit hole.
It is, but that's the beauty of science. There's always more to explore.
So we've got powerful telescopes, giant atom smashers. What's next? What's on the horizon for exploring the universe?
Well, the astronomical minute talks about even more powerful telescopes,
Bigger and better.
bigger and better, both on Earth and in space.
To see even farther, right?
Even farther, and there's this growing field, gravitational wave astronomy.
Oh, yeah, we've heard about that.
We detected ripples in space-time caused by, colliding black holes.
Yeah.
Imagine what we could learn with even more sensitive detectors.
We could study events that are totally invisible to regular telescopes.
Exactly. It's like opening a new window into the universe.
It's pretty mind-blowing to think about what the future holds for our exploration of the cosmos.
It is, and as we delve deeper into these mysteries, we also have to consider the philosophical implications.
Right. What does it all mean? Where do we fit in?
Exactly. How does our understanding of the universe shape our perspective on our place within it?
Big questions.
Big questions. And the astronomical minute wraps up by reminding us that as we explore the universe, we are also exploring ourselves.
It's a journey of self-discovery.
It is. The vastness of the cosmos, the laws that govern it, our own existence, it all makes you think.
Makes you think about those fundamental questions, our place in the grand scheme of things.
It's both humbling and inspiring.
It is. It's humbling to realize we're part of something so much bigger than ourselves.
But it's also inspiring to know that we have the capacity to understand and explore it.
Well said. And to our listeners, we hope this deep dive into the edge of the universe has left you with a sense of awe and wonder.
Keep looking up at the stars, keep asking those big questions, and never stop exploring.
The universe is out there waiting to be discovered. Until next time, keep exploring.